In this video here, we're going to take a look at exam revision for functions and graphs. So for this video then, all we're going to do here is run through a few exam style questions for functions and graphs. And as you can see then, this will cover the following topics here. So we start with the modulus function, we then have functions and mappings, we then look at sketching modulus functions, and then finally here to finish with, we have combining transformations. So as always then, what I'd recommend here is that you pause the video and have a look at the questions as they appear, and then just double check that your solution matches what we get on the screen. So that should give us everything that we need here to get started. Let's begin now with question 1. So to get us started here then, we have question 1, and for question 1 here we're given the point A, which has coordinates of 4, -2. And we're told that the point A lies on the curve with this equation, y equals f of x, where x belongs to the set of real numbers. The question then asks us to find the point to which A is mapped when the curve with this equation, y equals f of x, is transformed to the curve with these given equations here. Okay? Now for the first part then, part A, this really should be pretty trivial at this point, right? Because this transformation here wouldn't look out of place on a GCSE maths paper. And the reason for that then is because this here represents a horizontal translation. Okay? So we have y equals f of x minus 2. So what we've got here then, as we've just mentioned, right, is a horizontal translation. Now a common mistake here then is to subtract 2 from the x coordinates, or in this case, the x coordinate. But we do the opposite of what we'd expect here. So if it's x minus 2, we add 2 to the x coordinate. Okay? Let's just make a note here then. So add 2 to the x coordinate. Okay, so in that case then, A here, the point A becomes, so if A was originally 4 - 2, like we just said, right, add 2 to the x coordinate, so A becomes 6 here for the x coordinate, and the y coordinate remains unchanged here, so we get 6 - 2 there. And there we have it, so that gives us the solution to part A, hopefully nice and straightforward there. So now for part B. So for part B then, we have y equals the modulus of f of x here. So y is equal to the modulus of f of x. Okay. Now don't forget then, if we take the modulus here of the full function f of x, what this does then is this reflects anything below the x-axis above the x-axis, right? So in that case then, all we're doing here is taking the modulus of the y-coordinate. Okay. So again, let's just make a note here. So modulus of y-coordinate. Okay. So in that case, then what we're doing here is taking the modulus of -2. The modulus of -2, or the absolute value of -2 here, is +2. So in that case then, A here becomes, so what do we get here then? Well, the x coordinate remains unchanged. We don't do anything to that. So A becomes 4 then for the x coordinate. And now for the y coordinate then, as we've just mentioned, right, we just take the modulus of the y coordinate, which in this case here gives us 2. So A becomes 4 and 2 there. Okay. So that gives us the solution to part B. And now the solution here for the very last part then, part C. We have y is equal to -2 f of 4x. Okay. Now, we just do need to be a little bit careful here. So when you have a combination of transformations such as this one here, we need to be careful that, BIDMAS is applied here. Okay. Now, for this example, it doesn't actually matter whether we apply BIDMAS. And the reason for that is because this transformation here, this -2f, this affects the y coordinates. Okay. So let me just do this in a different colored pen here. So this part is affecting y coordinates. So that affects y coordinates. And then the part inside the bracket here, let's do that in blue. So this part here, this affects the x coordinates. Okay. So because they're independent of each other, right, they'll have no effect on each other. It doesn't matter which order we apply these transformations, okay? But if we had two different transformations here that both affected, say, the y coordinates or the x coordinates, okay, then we would have to be careful on the order that we apply the transformations. But like I said, then, for this example here, it doesn't matter, okay? So let's go back to our original pen color here. So the -2 here, what that tells us then is we times the y coordinates by -2, okay? And I'll go back to the pen color here for the y coordinates. So times by -2, okay, like so. And then the x coordinates here, this 4x, again, just be careful, right? Very similar to example A here. Whatever's inside the bracket, you just do the opposite. So rather than timesing by 4 here, we times by the reciprocal of that. So we times by 1/4. Okay, so times by 1/4 there. So in that case, then, let's just apply these transformations here separately. Going back to my original pen color. So A here, so A becomes, so what do we get here then? So times the x coordinates by 1/4. So 4 times by 1/4, it's just the same as dividing 4 by 4, right? You just get 1 there. So A becomes 1 for the x coordinate. And now for the y coordinate here, times those by -2. So -2 times -2 gives us 4. Okay. So for part C then, A becomes 1/4 there. And there we have it. So this here was the solution to part A. This was the solution to part B. And this here then was the solution to part C, giving us a solution to question 1. So moving on to the next question here then, let's have a go at question 2. So for question 2 here, we're given the functions f and g, and they're given as follows. Now for the first part of this question here then, all we want to do is find an expression for the inverse of f of x here. So for part A then, so f of x here is equal to x all over x plus 5. Okay, so if we want to find the inverse here of f of x, to begin with, what we do then is we let y be equal to x over x plus 5. Okay, so let y be equal to x over x plus 5. Okay, like so. And what I need to do here then is rearrange for x. Okay, so to begin with then, let's times through by x plus 5 here. So I get y times x plus 5 is equal to x, like so. So now let's expand here then. So I get xy, so xy plus 5y is equal to x, okay? Now, clearly what I want to do here then is get all of the x terms, or any term involving x here, on the same side. So let's subtract xy here off both sides. In that case then, 5y is equal to x minus xy. Okay? What I can now do here is factorize on the right-hand side. So 5y is equal to x times 1 minus y. Okay? So we're pretty much here then. All we need to do now is just divide through by 1 minus y, right? And at that point then, we have rearranged and made x the subject. So therefore, x is equal to, so I get 5y all over 1 minus y. Okay? And then to finish with here, so what we wanted to do here was find an expression for the inverse of f of x here, so that's f to the minus 1 of x. So what we do then is we replace x here with f inverse of x. So therefore, f inverse of x here is equal to what we now do here with the right-hand side of this equation. So this equation here is replace any y's with x. Okay, so we get 5x all over 1 minus x there. Okay, and there we have it then. So that gives us the solution to part A. Now, before we continue then with part B here, please do just note this adjustment that I have made to part B. So the question originally said, or this part of the question anyway, did just say state the domain of the inverse of f of x. And as you can see now, then it just asks you to state the range of the inverse of f of x. So apologies for that, just a slight mistake on my part there. Well, for part B then, so let's just actually have a go then at stating the range of the inverse of f of x. You should be aware here that the range, so the range then of the inverse then of f of x here, so f to the minus 1 of x, is the domain. So this is the domain of f of x. Okay. So in that case then, the range here of the inverse of f of x is given as, we get f to the minus 1 of x belongs to the set of real numbers. So f to the minus 1 of x here belongs to the set of real numbers, like so. And the inverse then of f of x here cannot be equal to minus 5. So the inverse then of f of x, that's f to the minus 1 of x, cannot be equal to minus 5. Okay, I've run out of room ever so slightly there. I'll just drop it underneath. So the range then of the inverse of f of x here is given as follows. So f to the minus 1 of x belongs to a set of real numbers, and the inverse of f of x cannot equal minus 5 there. Okay, so that's what you should get there for part B. So now for part C then, what do we want to do here? So for part C then, all we want to do here is find the value of gf of 10. So gf of 10 here. Now clearly then, we're looking at composition of functions here, but in this example, quite nice and straightforward, right? Because all I need to do here is start by finding f of 10. So don't forget then, for composition of functions here, rather than working from left to right as we traditionally would with, say, English and maths, we work from right to left. So we begin then with f of 10 here. So f of 10, then is 10 over 10 plus 5. So 10 over 10 plus 5. So what we get here then is 10 over 15. Okay, now 10 over 15 just simplifies to give us 2 over 3. So what we now need to find here then is g of this here. So g of 2 over 3. Okay, like so. So gf of 10 is just equal then to g of 2 over 3. And for g of 2 over 3 here then, so just substitute 2 over 3 then into g of x here. So we get 4 over 2 over 3. So that's 4 all over 2 over 3, which in this case here then just gives us 6. Okay, so gf of 10 is equal to g of 2 over 3, which is just equal to 6 there. Okay, so there we have it then. That gives us the solution to part C. And then finally here then we have part D. So for part D then it says find the values of x such that g of x is equal to f of x plus 3. So let's just write that down here then. So g of x is equal to f of x plus 3. So g of x then is 4 over x. I get 4 over x is equal to f of x, which is x over x plus 5. So x over x plus 5. And then don't forget here the plus 3. Okay, like so there. So let's just cross multiply here then. So if we cross multiply, on the left-hand side, we get 4 times x plus 5. So 4 times x plus 5, like so. And now on the right-hand side here then, what do we get? So I've got x times by x here, so that just gives us x squared. And then I've got this 3 here, so I get 3 times x, and we also times that by x plus 5. So altogether, I've got x squared plus 3x times x plus 5. Okay, like so there. So let's just expand here on the left-hand side and the right-hand side here and simplify where possible. On the left-hand side, we get 4x plus 20. So 4x plus 20 there is equal to, I get x squared here. I've then got 3x times x, that's 3x squared. And then 3x times 5 is 15x there. Okay, so 15x there, like so. So what we need to do here then is basically just get everything onto one side here. So that one side of this equation is 0. And what we can do then is solve for x, right? And we're going to get a quadratic here, so we should get two values of x. So I've got x squared plus 3x squared there, so that's 4x squared. I've got 4x squared there. I've got 15x here. If I subtract 4x off both sides then, I get plus 11x. So plus 11x. And then finally, subtract 20 off both sides here. So we get 4x squared plus 11x minus 20 is equal to 0. Okay. Now the hope here then is that this quadratic here does factorize. And the good news then is that this does indeed factorize. So what we get here then is 4x minus 5 for my first bracket. And then for the second bracket here, we get x plus 4. Like so there. Okay. And this here then is equal to 0. And at this point here, we obtain two solutions. Like so. So this solution here, nice and straightforward, right? So apologies. So x plus 4 is equal to 0. In that case, then x is equal to minus 4. Like so. Nice and straightforward there. And then for this solution here, 4x minus 5 is equal to 0. So add 5 to both sides, divide through by 4. And in that case, then x is equal to 5 over 4 there. We get 5 over 4 there, like so. And there we have it. So x equals 5 over 4 and x is equal to minus 4. So there we have it then. That gives the solution to the second question, question 2. So moving on to the penultimate question here then, where we have question 3. So for this question here, it asks us to sketch the graph of y equals ln of the modulus of x, and the question also asks us to state the coordinates of any points of intersection with the coordinate axes. So for question 3 then, let's just begin here by drawing the x-axis and the y-axis, right? So our coordinate axes here. Now, just to warn you, right, it doesn't have to be perfect, by the way. If you've watched any of my videos before, you'll know then that my art skills, if you see me draw a diagram, are certainly not the best. So it doesn't matter too much as long as you can kind of make out what we're trying to do here. So I've got my y-axis here, like so. And we've also got our x-axis here. Okay, again, it doesn't have to be perfect, right? So that's my x-axis, and this here then is my y-axis. Okay, so not too shabby there. It'll do for now. So to begin with here, what I'm going to do then is just sketch y equals ln of x, okay? Because if we know what this looks like here, so we know the shape then of y equals ln of x, we can easily sketch this graph here, okay? So y equals ln of x then, you should recognize that this looks like the following. It's going to look, say, something like this, okay? It's not perfect, but you get the idea. And we'll get something like this. Okay, so as we've just mentioned then, this is y equals ln x. And y equals ln x then. So this doesn't have an intersection here with the y-axis, but with the x-axis here then, that point is x equals 1. Okay? So that's y equals ln x, but what we want to sketch here then, and let's do this in green, is y equals ln of the modulus of x. Now don't forget then, if you take the modulus here of the argument of your function, what happens then is we reflect here in the y-axis. So in this case then, anything to the right here of my y-axis is going to reflect to the left-hand side of my y-axis. Okay, so shouldn't be too challenging here to sketch, right? Again, let's do kind of a general outline. We'll get something that looks, say, like this. Okay, if we join this up then, we'll get something like this. Okay, That's pretty decent for my art skills anyway. So this here is y equals ln of the modulus of x there. Okay. So the only thing that we're missing here then is the coordinates here of the points of intersection. So if y equals ln x cuts through at 1, y equals ln of the modulus of x will cut through at -1. Okay. So this point of intersection here is -1, 0 there. Okay. That one obviously being 1, 0. But there we have it. So hopefully quite a nice easy question really. Nothing too challenging there. So that gives us the solution here then to question 3. And then finally here we have the very last question, question 4. Now for this question here, we just want to solve this given equation. And we can easily do this then by just considering the positive and the negative argument of the modulus function. Okay. So to begin with then, let's just consider the positive argument here of the modulus function. So for the positive argument here then, what do we get here? So the positive argument of the modulus function here would just give us 3x minus 1. We get 3x minus 1 is equal to a half x plus 9. Okay. And at this point here then, nice and straightforward, all we need to do is just solve this given, well not given, but just solve this linear equation here. Okay. So let's just subtract a half x off both sides. So in that case, then we get 5 over 2x here minus 1 is equal to 9. Okay. Next step then is just add 1 to both sides here. We get 5 over 2x is equal to 10. And then finally here, just divide both sides by 5 over 2. And in that case then, x is equal to 10 divided by 5 over 2, which gives us 4. Okay. So we found the first value of x here. We can also obtain a second value of x here by considering the negative argument. Okay. So now for the negative argument here, again, let's just write this down. So in that case then, for the negative argument here, we're just going to get minus 3x minus 1. So minus 3x minus 1 is equal to a half x plus 9. So a half x plus 9 there. Okay. So let's just expand the left-hand side here. So in that case, we get minus 3x plus 1. Obviously, just be careful with the signs here. So minus 3x plus 1 is equal to a half x plus 9. Okay. So now for the next step here, let's just add 3x to both sides. So in that case then, I've got a half x plus 3x. That gives us 7 over 2x here. So I get 1 is equal to 7 over 2x plus 9. Okay. Now let's subtract 9 off both sides here. So in that case, then we get 7 over 2x is equal to 1 minus 9. So that gives us minus 8 there. And then finally here, to find the value of x, all we need to do then is just divide both sides by 7 over 2. So in that case then, x here is equal to minus 8 divided by 7 over 2. And that gives us minus 16 over 7. Okay. And there we have it then. So we've solved this equation here, and that gives us the solution to the very last question, question 4. And that actually brings us to the end then of this video here on exam revision for functions and graphs.